Thank you so much for taking the time to join today to hear how advanced membrane chemistry can really help you to improve your overall landfill leachate OPEX. And let's start with very brief intros of our speakers so you know who you have here. And let's start with you, Elke, first.
Hi, everyone. I'm Elke Pertzigali. I'm a senior product manager here at ZwitterCo, and I focus on all of the RO products that ZwitterCo offers, but I'm particularly excited to be talking about our RO products for landfill leachate treatment.
Excellent. Thank you so much. And then Brett.
Thanks, Katarina. My name's Brett Thompson. I'm a senior application engineer at ZwitterCo, primarily focused on industrial wastewater and landfill leachate treatment for our superfiltration and our RO products.
Excellent. And last but not least, my name is Katarina Mayama, and I lead the product management and strategy for ZwitterCo's water and wastewater offerings, also including the landfill leachate. And without the further ado, let's dive straight into the topic and get everybody aligned on the key terms, starting with what's actually landfill leachate. So landfill is an area or excavation in which waste material is placed for permanent disposal. Landfill leachate is the liquid that drains or leaches from a landfill as water percolates through solid waste. As the water draws different chemicals and constituents from the waste itself, it forms a stream which is potentially hazardous and includes a wide range of different pollutants. Managing and treating this leachate effectively is crucial to any landfill to prevent environmental contamination, comply with regulatory standards, enable different levels of water reuse, and overall reduce the costly surcharges that are associated with the waste disposal. Now, there are many challenges associated with the landfill leachate treatment. And as Stephanie mentioned, this is an interactive webinar, so we'd love to hear straight from you, what's the most pressing item on your mind today? So let's do a quick poll to hear what are the main challenges or goals that you see with landfill leachate treatment. Simply click on the box that best describes your situation. Let's see what the verdict is. We have a really good mix of different items. So that is great to see. We hope to have a good content for each of these situations with the content that we have here today. So then moving on to the leachate management, what are the typical options that you would have in the most simplistic form? Traditionally, especially here in the US, leachate is managed by collecting it and then transporting it to an off-site treatment facility, such as a nearby municipal wastewater treatment plant. While this option has been widely used, it has a risk to become very costly and also risky for the future-proofing the operations. While the volume load from a landfill leachate to a municipal wastewater plant may be very small, the water is loaded with different organic contaminants such as nutrients, heavy metals, and also emerging constituents such as PFAS. And those are items that the wastewater plant may not have the capacity to handle any longer in the future. The second option, therefore, is to have on-site treatment plant to treat the leachate for either discharge or reuse. And this is the option that we'll look a little bit closer. So in a bigger flowchart, leachate treatment systems are always tailored to the specific leachate profile of the site. And that can vary a lot depending on the age of the site, the size or contamination load, where the waste is coming from, as well as also the rainfall levels that the site sees, for example. Most typically, you'll always have a pre-treatment. It's a must, and that is in place to reduce the burden on the subsequent treatment stages. The treatment itself can be done in multiple ways, utilizing either traditional or membrane-based biological processes, or simple membrane-based treatments that we start to see more and more often. The permeates or the treated leachate stream is either safely discharged when permits allow or reused back at the landfill site for other operations, always ensuring the compliance with the local environmental standards. And the residual streams can be then recirculated back to the landfill, hauled off, or in some cases even evaporated. As you can see on the slide, we have reverse osmosis membranes frequently showing up as a treatment option. RO, as the finest level of filtration known, is gaining a lot of ground as the technology of choice, as it can effectively remove up to 99% of dissolved salts and contaminants in leachate. This also includes removing or reducing the levels of concerning constituents, including the nutrients such as ammonium, nitrogen, or phosphorus, heavy metals, and the emerging compounds like PFAS. Whenever RO is utilized, the pre-treatment step is always needed to remove the suspended solids, and that is something that is a must with any RO treatment. Brett and Elke will be diving deeper on the technology next. But before I hand it to Brett, let's continue with the interactive mode. So we have a big audience listening in today, and it would be great if you could let us know a little bit more about yourself and why you're attending on this, this webinar today with the quick poll. And I think we have a good set of answers in, so let's look at them. And excellent, we have a good spread as well on different roles. So good to hear you, and thank you for answering. And with that, I'll hand it to Brett next.
All righty, thank you, Katarina. So yeah, we're going to go ahead and dive a little bit deeper into one potential treatment scheme for landfill leachate of the various options that Katarina went into earlier. So as you can see here, typically landfill leachate is collected from the landfill, and then it's typically pumped to some sort of storage, either a pond or a storage tank, outdoor storage tank. From there, like Katarina mentioned, there's typically some level of pre-treatment prior to a membrane-based system. So in this example, we show a guard filter, which could be cartridge filter, could be a multimedia filter, some sort of method to reduce the suspended solids. In this example, we also show a superfiltration system, which is optional. Superfiltration is a type of filtration that falls in line between nanofiltration and ultrafiltration, and is really good for leachates that have higher levels of fat, oil, and grease. But not always 100% necessary, because we can also just feed directly to an RO system. Now, landfill leachate qualities can vary greatly depending on many factors: the location, the amount of rainfall, the type of solid waste that it receives, the age of the landfill. So for an RO system, we're typically, one of the first things we're looking at is the TDS, or total dissolved solids. It can vary as low as 2,000 milligrams per liter, upwards of 60,000 milligrams per liter, depending on those factors that I mentioned earlier. And so because of this, RO systems treating landfill leachate, typically the first pass would be a high pressure pass, able to go up to higher pressures to withstand to produce enough osmotic, or to overcome the osmotic pressure of the leachate and produce a discharge that's suitable for discharge either to surface water in many cases, discharge to sewer, or could be reused for dust control. So landfill leachate typically has high levels of organics, usually measured by chemical oxygen demand, COD, BOD, and then, like I mentioned before, fats, oils, and grease. Those can all become issues for the first pass of RO, which is going to be seeing the brunt of the organics coming in. So, over time, RO membranes, especially the first pass, can become fouled, which we'll talk a little bit more about on the next slide. In many cases, you're also trying to, like Katarina mentioned, reduce nutrients like ammonia, which can come in multiple thousand parts per million in your feed. For surface discharge in the US anyway, you're usually trying to get that down to 5 parts per million or less. So many times it'll take multiple passes of RO to get to that point. PFAS as well, you know, limits are looking like they're going to be really low, on the order of 4 parts per trillion for many of the PFAS parameters. So for that, you're also probably going to need multiple passes of RO. So from there, the residual from both the RO and the superfiltration can go to different ways. You could either recirculate it back into the landfill. This is what a lot of landfills do. So essentially, you're reducing the overall water, you're dewatering the landfill by sending a small proportion back to the landfill. Or you could send that residual to a thermal evaporator for further reduction of flow. And from that point, you could either send the slurry back to the landfill or take it elsewhere. So that leads us into the big challenge, treating landfill leachate with spiral wound membranes, which is organic fouling. Organic fouling is a big issue. It happens when you have organic material that accumulates on the surface of the membrane. It'll impact operation because it'll cause your pressures to increase, your flux to decline, and ultimately you could have irreversible organic fouling where it can't be removed. So yeah, typically when fouling occurs, you would clean the membrane using, typically for leachate, formulated cleaners, really high pH. It could take, a long time to remove the foulants from the surface of the membrane. But over time, you actually might not see restoration anymore because you're going to have so many organics getting into the surface of the membrane and the pores that it'll irreversibly foul. Once you get to that point, really your only option is to replace the membranes. So organic fouling, these are some of the things that it can cause. You have increased costs associated with those chemical usage and chemical and cleanings that we discussed before. Some landfills are cleaning their RO membranes as often as every day or every other day, but typically it's at least once per week. So there's a cost associated with that. The more that you clean an RO membrane, you're actually degrading the surface of the membrane over time. That will cause the permeate quality to decline because you're not going to be rejecting as much. And that could cause issues meeting your discharge limits. Like I mentioned before, if you do get irreversible fouling, ultimately you're going to need to replace the membranes, which there's a cost associated with that. And one other factor that should be considered is downtime. Downtime causes issues because you might have an operator that's doing other things at the landfill. They're not concerned with running the RO system all day, every day. And so obviously it's time for them. They need to come and clean their RO membranes. And then also, if you're not running your membrane system, you're going to start accumulating leachate in your feed tank or your ponds. And when that gets full, you have to do something with your leachate. So there's costs associated with hauling the leachate elsewhere for disposal, which are usually much higher costs than actually just running the system properly. So all of these, like I mentioned, result in costs because you're going to be cleaning most likely at least once per week. And then do the organic fouling, replacing your elements every year or so, sometimes much more frequently. This slide kind of shows some quotes that have been happening for over a long period of time. Membrane organic fouling has been a long challenge that we've been sort of facing in the membrane industry, especially with landfill leachate. Organic fouling reduces the life of membranes and requires replacement. There are products on the market already for low fouling and fouling resistant membranes, but many of these are traditionally just standard polyamide RO membranes that have been treated or coated with a secondary chemical. that gives us some anti-fouling properties, or have feed spacers that allow for different hydraulics through the feed channel of the membrane that help minimize the effects of fouling. But even with these developments, we've sort of seen that irreversible organic fouling still occurs, especially with landfill leachate, and they don't necessarily reduce the operating expenses or of that over a standard RO membrane. So with that, we'll go into the next poll question. So the question here is, do you currently use RO membranes? Yes, no, or no, but I'm interested in using them. All right, once again, very even split we have here. About equal numbers, yes, no, and so I'm interested. That's great. All right, so that sort of leads into the innovation. So, because reversible organic fouling still remains a big challenge despite low fouling or fouling resistant solutions, researchers, companies have been trying to develop ways to circumvent this for years. We've been kind of looking for the next step change, revolutionary type change to get beyond organic fouling. So one of these new solutions relies on the power of Zwitter ions. So Zwitter ions are small compounds, organic compounds, that have an equal number of positively charged and negatively charged functional groups. They have an overall net neutral surface charge per charge. This Zwitter ions are extremely hydrophilic to the point of being hygroscopic or water-loving. If you had a jar of Zwitter ions, it would actually whip moisture out of the air, become a goopy mess in no time. But because of this hydrophilicity, people have been trying to incorporate Zwitter ions specifically into membranes for a long time. So ZwitterCo has come up with a new method of doing that by incorporating copolymers. So Zwitter ionic copolymers, the copolymers provide a strong backbone, and the Zwitter ionic copolymers actually self-assemble into a pore structure, creating a Zwitter ionic membrane that's extremely hydrophilic, more so than any other material chemistry on the market for membranes. Because of this, these membranes actually repel organics and are able to recover from organic fouling even after treating high-strength wastewater like landfill leachate. So for the next slide, we'll just show a video of a Zwitter ionic membrane in action. This is a membrane that has seen inorganic wastewater and become fouled. But this video just shows a quick time lapse of just a water flush, no high pH, just the RO permeate quality water being used to flush the organics off the surface. So this is really just a demonstration to show that organics don't stick to the surface of the membrane and can be easily flushed off. And with that, I will go ahead and turn it over to Elka.
Thanks, Brett. As Brett mentioned, organic fouling is a significant challenge when it comes to using RO membranes for landfill leachate treatment. It causes frequent cleaning, short membrane life, and high operating costs. So, as Brett has explained, ZwitterCo has developed a new material chemistry using Zwitter ions that offers unprecedented fouling resistance. So what does that mean for users treating landfill leachate? Well, like we saw in the video that Brett just shared, thanks to the Zwitter ions, organic material cannot adhere to this membrane surface. This means this membrane does not require as many chemical cleanings to remove those organic foulants. And because, like Brett mentioned, cleaning chemicals do cause membranes to deteriorate over time, this reduction in cleaning frequency means that these Zwitter ionic membranes should also last longer than conventional membranes. Now, if this membrane doesn't require as frequent chemical cleanings and lasts longer than conventional membranes, this significantly reduces the operational costs for users treating landfill leachate. So let's dive a little deeper. How do you benefit from this membrane? So the first is you can save money. Because Zwitter-ionic RO membranes are less susceptible to organic fouling, you won't need to perform as much maintenance on your RO system. If you're spending less time shutting your system down to perform those chemical cleanings or replace those elements, you're saving both time and money. Not to mention the costs, on chemicals or hauling or trucking that waste elsewhere. You'll also benefit from longer element life. As we mentioned, cleaning kills membranes. So minimal chemical use ensures stable performance for years. Because ZwitterCo RO doesn't require as many alkaline cleanings, the membrane won't degrade as fast as conventional membranes, meaning they will last longer. Operate with peace of mind. With the world's most fouling-resistant RO membrane using those Zwitter ions, you can have peace of mind or have confidence that your RO system will run smoothly. You'll also benefit from not having to deal with chemicals. Less chemical use leads to less chemical handling, storage, spills, etc. Less cleaning also means operators can spend their efforts on other responsibilities. Restore performance. As we said, biology and other organic material cannot stick to or grow on the Zwitter ionic surface, and cleaning will easily restore performance. Last but not least, it's an RO element, but much better. No new equipment or system modifications are required to implement this technology. We really wanted this technology to be easy to implement. We offer RO elements in the same industry standard sizes you're used to, so that you can easily remove the elements you're currently using and replace them with these. So now let's take a look at some landfill leachate case studies using ZwitterCo RO membranes. Okay. So this first site is a landfill in the US. The site collects leachate in a pond on site and uses an RO system to treat that leachate so that the pond doesn't overflow, specifically during the rainy season. This site historically has replaced their conventional RO elements every other day due to rapid fouling. The organics were quickly settling on the membrane surface, causing the system performance to decline quickly. The organic fouling in the system caused the system to lose permeate flow. Because the fouling at the site was so severe and they were replacing elements every other day, the site chose to implement ZwitterCo RO elements. By implementing ZwitterCo RO elements and by making a few operational modifications, the site saw some immediate benefits. The site was able to run for 7 weeks without element replacements. They've since temporarily paused operations because it hasn't been raining and the pond isn't overflowing. But due to the fact that they had less fouling, more stable operation, and less frequent element replacements, the site has significantly reduced their operating costs and are looking to install ZwitterCo RO elements in other leachate treatment systems at other landfills. Now let's take a look at another site in the second largest city in France. So this site was using a 2-pass RO system in order to treat their landfill leachate to meet discharge requirements. The site was cleaning the first pass of their RO system every other day, or 180 times per year, and replacing elements every 2 years. Because they were cleaning with formulated cleaners, this was costing them significant amounts of dollars. By installing ZwitterCo RO elements in the first pass, which is where they saw most of the organic fouling, the site benefited from only performing 1 chemical cleaning in the first 2 weeks of operation And since then, the site implemented preventative cleanings every week to ensure reliable operation. However, because things were going so well, they pushed out these preventative cleanings from every week to every 10 days, and we're very happy with performance. By reducing the cleaning frequency from every other day to every 10 days, they've reduced their cleaning frequency and cleaning costs by over 80%. Needless to say, the site is very happy with how things are going and have said that less chemicals, longer run times, and less maintenance have made it easier for their team to operate the system. So let's take a look at another landfill in France. Now, this landfill has a low strength or light leachate, meaning the TDS levels are lower than the previous two examples. The site uses RO to treat the leachate so that they can reduce the waste volumes that are hauled off-site for treatment. They also reuse the permeate for cleaning or dust control on site. However, because of the high level of organics, the site was cleaning this RO system every 24 hours and replacing those conventional RO elements every 4 to 6 months. During the first months of operation with ZwitterCo RO, however, the site noticed a slower rate of fouling, reduced cleaning frequency and cost, and because of that slower rate of fouling and reduced cleaning, they expect the ZwitterCo RO elements to last much longer than the conventional RO elements they were using previously. So, in general, ZwitterCo RO elements are proving to significantly reduce the cleaning frequency at these landfills. By reducing the cleaning frequency from organic fouling, users will experience less system downtime, allowing them to benefit from longer run times and reduced OPEX. So let's take a look at an economic model to highlight the potential savings. So let's say we're looking at a landfill that is similar to the one in France that's cleaning every other day. Let's also say that the conventional RO elements are lasting 1 year because they're dealing with lots of organic fouling challenges and cleaning so frequently. Because the site cleans their RO elements every other day or 180 times per year, they're also suffering from significant downtime costs. Their goal is to run for longer periods of time between cleanings, which would equate to reduced OPEX. If the site were to install ZwitterCo RO elements, they wouldn't have to clean the system as frequently. So let's assume they cut the cleaning frequency down to about once a week, or a 67% reduction in cleaning frequency. And by exposing the membrane to less chemicals, the elements will last twice as long. So let's say the elements last 2 years instead of 1. Because the ZwitterCo RO elements require less frequent cleaning, less downtime, and last longer, the ZwitterCo RO elements provide a value of over $2,000 per element per year. This is significant. It's also worth mentioning that this model focuses on an existing RO system that just replaces conventional RO elements with ZwitterCo RO elements. But if you were looking at a new RO system, there are additional opportunities to gain further benefits with ZwitterCo RO. There is potential to increase system recovery and or operating flux compared to conventional RO elements, which would, of course, further reduce your OPEX. So how do you get started? Well, because landfill leachate contains higher total dissolved solid concentrations, like Brett was mentioning, most sites are seeing 20,000 to 60,000 milligrams per liter. They often require elements that can operate at higher pressures. So ZwitterCo currently offers 2 different high pressure RO elements. One features a 34 mil feed spacer. The other features a thicker 50 mil feed spacer. All of these elements are available in industry standard sizes that fit into RO pressure vessels, meaning these elements serve as a drop-in replacement for existing RO systems. Again, no system modifications or additional capital investments are needed to implement this technology. So with that Q&A session, so I believe we are ready for the Q&A session. So Stephanie?
And our first question comes from Evan. What screening processes were in place of the landfill case study in the US with the original system? Were there any additional processes and equipment included in the upgrades with the ZwitterCo membranes?
I'll go ahead and take this one. So the site that was in the US, they just had some basic like cartridge filters upstream of the RO system, and we didn't make any changes there. It literally was a drop-in replacement. We basically just recommended that they take out the current RO elements that they were using and replace them with the ZwitterCo RO elements and run them the same way. So just due to that additional fouling resistance with our membrane technology, they were really able to see that reduced fouling, which led to the reduced cleaning and lower OPEX.
Okay, our next question comes from Deborah. If multiple passes are required through the RO method for PFAS chemicals, for example, is there existing methodology or machinery to do that, and is the cost the same for each pass?
I could, I think, address that. So for PFAS, with using RO, you're going to have multiple passes. Each pass is going to see really high rejection, upwards 99% or higher for the longer chain PFAS molecules, and above 90% for the shorter chains as well. The second passes of leachate treatment typically are treating the permeate from the first pass. So they're going to be much less susceptible to fouling. So you would typically run those at higher permeate flux or permeate flow. And so it wouldn't require as many membranes to get to your to treat the permeate, essentially.
Yeah, most typically, if sites are using the two-pass RO, that is because of the nutrients and especially ammonium that is present in very high quantities and is the hardest one to reject by RO.
Okay, our next question comes from Thorsten. If you talk about high pressure RO, which pressure level will a ZwitterCo membrane withstand? Which pressure is it designed for?
I can jump on that one. So our high pressure RO elements are able to withstand up to 1200 PSI.
And this question comes from Paulina. What is the management plan? What is the management plan for disposal of spent membranes? And are those spent membranes sent to landfills and incineration?
I can take this one as well. So in general, yes, when an element has reached its lifetime potential, meaning it's no longer really meeting your requirements, those elements are removed and then they are disposed of. So that's just another benefit with these ZwitterCo RO elements. If you get that longer element life, obviously you're going to be sending less waste to landfills. So there is that benefit as well from the sustainability environmental aspect.
And our next question is, how do you reduce or eliminate PFAS?
I can take that one. So since I was talking about it, so RO as a technology does not eliminate or reduce or destroy PFAS on its own. So what RO does, it enables to up-concentrate that. So in the cases, especially US landfills, where you would be hauling the leachate into a wastewater treatment plant, that can be a significant contribution of PFAS. So if you move into on-site treatment, then you're eliminating it from the or reducing the load at the municipal plant. On the leachate side itself, up concentrating the leachate or the PFAS concentration can make it easier to treat with alternative technologies that are really destroying PFAS. So the economics can be better once you get the PFAS into higher concentration in the water stream.
And do you have your own projection software?
Happy to jump on this one as well. At this point, we are currently developing our own projection software, but we can say that our RO membranes have very similar performance as conventional RO elements in terms of rejection and flow. So if you ever need a projection, please reach out to us directly and we can certainly help support you with that.
Okay, our next question is, roughly how much more experience is your RO in comparison with typical RO?
I can take that in terms of experience. If we're looking at the life or how long they've been operated. So overall, ZwitterCo is a fairly new company in the reverse osmosis space. So we have our longest installation is running over a year. So we definitely are a newer player in the RO market, but quickly making great experiences when it comes to treating very challenging streams such as landfill leachate.
Can you supply the RO to Sweden as we are working in Sweden? And is there any difference in your cleaning regions in comparison with typical RO?
So I'm happy to take this one as well. So yes, we can certainly supply in Sweden. That's not a problem. And then I think the second part of the question was the cleaning. So whereas you might use formulated cleaners for conventional RO, with ZwitterCo RO, we just suggest caustic and hydrochloric acid as your cleaning chemicals. So they're just commodity chemicals.
And this is referring previously. Do you have any comments on the expensiveness of the RO in comparison to other ROs in terms of cost?
So in terms of the cost of the elements, that's typically we would compare and look at the value, what we are delivering for the system in case. Elke was sharing the example of the cost calculation. There is a significant value to be generated with the Zwitter ionic technology, and that's something that we expect to see as the full significant benefit for the user as well.
Next question comes from Sam. Is there more passage of contaminants expected with the high hydrophilic nature of the membranes?
So I'll chime in here again. So no, I would expect, again, very similar rejection performance, compared to other RO membranes that are currently available. So just because we have this, hydrophilic Zwitter ionic technology, that's not going to increase passage of certain contaminants. It should be the same.
Do you need to use specialized cleaning chemicals with your ZwitterCo elements?
Yeah, so I think this is pretty in line with a previous question that we got. And we don't foresee the need for using special cleaning chemicals. At this point, we've seen a lot of success with just using caustic for those high pH or alkaline cleanings, which are used to remove those organics. And then if an acid cleaning or low pH cleaning is needed, we just typically recommend hydrochloric acid. So no special cleaning chemicals required to clean the ZwitterCo RO elements.
And here's another question about chemicals. Can ZwitterCo membranes be resistant to free chlorine?
Yeah, so our Zwitter ionic technology itself is resistant to chlorine, but when it comes to the RO product, we have the Zwitter ionic technology integrated with the polyamide RO membrane. So the polyamide is really the limiting factor. So no chlorine for the RO products, which is very similar to conventional RO elements that are available today.
And here is a more technical question. With landfills in Chile, they have a high concentration that requires post-treatment with ion exchange. What is the boron removal capacity of ZwitterCo membranes?
Great question. I think this is something that we are still looking into to get more information on, but happy to follow up offline with more information on that question.
What is the maximum oil and grease concentration allowable to feed the membranes?
Brett, do you want to answer that for SF?
Yeah, so I would say so typically, you know, if you have oil and grease coming in with your landfill leachate, that's where we would recommend using superfiltration ahead of the RO. In that case, we really don't have an upper limit. As long as it's emulsified oil and grease, we've seen over 5% in the concentrate for the residual. So yeah, we would recommend superfiltration if you have higher levels of oil and grease coming in.
And do you have any insights into cow or pig manure?
Yeah, so I could say for that, you know, we do, we've seen success with superfiltration for that as well. You know, it'd be a part of a treatment train where you're gonna have pre-treatment going to RO afterwards. And if, you know, it would also, cow manure would also be good. We're talking about digestate here. You could also have, you would need some sort of pre-filtration, and then you could send some of the organic laden permeate to ZwitterCo RO. That would also be a good example, you know, where you could use that for manure.
Just have one more question. Do I need to pilot with these elements first?
No, you don't need to pilot, at least with the RO elements, you do not need to pilot with them first. Like I mentioned, they are a drop-in replacement. So if you have a current RO system, it's a plug and play. So you can put these elements into your system and start operating tomorrow, and reap the benefits from, you know, reduced cleaning and, you know, longer element life, reduced OPEX, etc. So no piloting is really necessary here.
Before we sign off, I would like to thank our presenters, Brett, Elka, and Katarina, as well as our sponsor, ZwitterCo. Thank you so much for attending and have a wonderful remainder of your day.